Time domain analysis of second order circuit. Time domain analysis of second order circuit. For example, there is the circuit diagram plus minus 4 ohms. Okay, and this is called inductance. So 1 Henry. This is called 2 ohms. This is called switch. This switch is connected like this, for example. And this is called capacitor. Capacitance 1/2 farads. Okay, your voltage is called 12 volts. For example, the switch is closed at 10 milliseconds. Let us assume the switch is closed at 10 milliseconds. Okay, this is called ground. For the following circuit, find complete expression. Find complete expression. Expression V of t. That is called here. Voltage across the capacitor or voltage across this. Okay. So this is our question. So by using this circuit diagram, we have to verify the results by using PSpice and verify the results by using PSpice. Okay. By using PSpice, we have to verify the results. This V of t expression is correct or not. Okay. So here first initial conditions exist or not. We have to find initial conditions exist or not. That means before switching action. That means t is less than 10 milliseconds. T less than 10 milliseconds. The circuit is open. Am I right? The switch is open. At t is equal to 10 milliseconds only, the switch is closed. So that means this circuit will become like this. It initially at 10 t is less than 10 milliseconds means at t is equal to 0 minus or t is equal to minus infinity. That means V of 0 minus. Initial conditions exist or not. Okay. We have to find across the capacitor. Okay. So at t is equal t less than 10 milliseconds means V of 0. So the circuit for this condition, the circuit will become like this. Here 4 and t is equal to minus infinity condition. T is less than 10 milliseconds means at t is equal to minus infinity also. Okay, at t is equal to 0 minus. That means steady state condition. Before switching action, there is a steady state condition. Okay, steady state condition is there. So because of this, inductor completely short circuit. Inductor short circuit. This switch is open like this. This is called 2 ohm, and this is called plus minus. Okay, this source is connected like this, and this is called 4 ohms, and inductor is short circuited, and 12 volts, and then capacitor. The steady state condition, capacitor, inductor acting as a short circuit, capacitor acting as an open circuit. Am I right? So that means here the circuit will become like this. At t is less than 0. That is called one of the steady state. Okay. This is called V of 0 minus. So that means the current in this circuit is equal to 0 because of capacitor is fully charged. Therefore, it is open circuit. Then voltage across the capacitor is nothing but 12 volts. So this is the condition, initial condition. So that is called V of 0 minus is equal to 12 volts. And current 0, no? That is called current flowing into the inductor of 0 minus is also is equal to 0 amps. These are the initial conditions. Okay. If initial conditions exist like this, then how can be write the circuit into S domain? Means for capacitor, we can write for capacitor. So like this. This can be written in S domain 1 by CS, and initial conditions are exist. That's why plus minus V of 0 minus or V of 0 divided by S. You have to write this for capacitor. For if it is inductor, initial conditions are exist, so you have to write LS and then minus plus L into I of 0 minus or I of 0. So like this we have to write okay, for capacitor energy storage element. For capacitor like this we have to write. Okay, for inductor, so we have to write like this if initial conditions are exist. Okay, so across the inductor initial conditions are no, there is no initial condition because of 0 amps, but across the capacitor initial conditions are exist, that is called 12 volts. Then the circuit can be drawn like this. So this is called our constant voltage plus minus 12 volts. This can be written in S domain 12 divided by S. Okay, and a resistor as it is 4 ohms and the inductor LS. Inductor can be written as LS. Inductance is called 1 Henry, that's why only S. Okay, and then switch is closed. After t is greater than 0, the switch is closed. So it can be written as like this. In S domain, it can be written, it can be drawn like this, the circuit. Then this is called capacitor. No? So capacitor can be represented like this. So how much here? V of 0 divided by S means V of 0 divided by S. That means 12 divided by S. Here 1 by CS. C is equal to 1 by 2 farads, 0.5 farads. That's why 2 by S. So this is how much resistance? 2 ohms. Okay. This is nothing but we have to find here voltage across the capacitor is nothing but V of S. Like this. So that is nothing but here. This is called V of S. Right? These two are connected in parallel. That's why this is called V of S. Then by using nodal analysis, so what is the current in this direction? V of S minus 12 divided by S. Okay, by 4 places. Okay, and then next V naught of S by 2. This current, and then this current is nothing but V naught of S, V of S minus 12 divided by S by 2 by S is equal to 0. Like this, we will get this expression. Okay. Simplify this expression, you will get V of S is equal to 12 S square plus 48 S plus 24 divided by S cube plus 5S square plus 6S. This can be written like this: 12S square plus 48S plus 24 divided by, this can be written like this, s into, okay, s plus 2 into s plus 3. So this is nothing but s cube plus 5s square plus 6s. Okay. So this can be divided into like this by using partial fractions. Okay. For example, this is equal to a by s plus b by s plus 2. Okay. And then c by s plus 3. C by s plus 3. By using partial fractions, find a and b and c. Okay. For example, if you want to know a, okay, in this expression, substitute s is equal to 0. 12s square plus 48s plus 24 divided by, don't take s, only s plus 2 and s plus 3. Substitute s is equal to 0, you will get 12s square 0 and 48s is 0 and only 24 divided by s0, 6. That is nothing but 4. A is equal to 4. Okay. Similarly, B. So substitute s is equal to minus 2 in this equation. 12s square plus 48s plus 24 divided by s into s plus 3. Substitute in this equation, you will get b is equal to 12. Similarly, C at what s is equal to minus 3. Then substitute C. How to find C means by substituting minus 3. So that is equal to 12s square plus 48s plus 24 divided by s into s plus 2. Substitute in this equation, you will get minus 4. Okay, A is equal to 4, B is equal to 12, and C is equal to minus 4. And then A is equal to 4 here, B is equal to 12, C is equal to minus 4. Understood? Here, then V of S is equal to A, it's called 4 by S. Okay, and then B, how much? 12 divided by S plus 2. C, minus 4 divided by S plus 3. Apply inverse Laplace transform. Apply inverse Laplace transform. Then you will get V of t is equal to 4 plus 12 into e power minus 2t minus 4 into e power minus 3t. This is called complete expression. Voltage across the capacitor for t greater than or equal to 0. Okay. So like this, we will get the results. Complete expression of this circuit. Okay. V of t. So this can be verified by using this expression can be verified by using p-space. Okay, but at t is equal to 0, t is equal to 0, that means initial conditions. Okay, so what is the voltage? 4 plus 12 minus 4, that means 12 volts. Voltage across the capacitor at t is equal to 0 initially. So this is the voltage, V is equal to, and then under steady state condition at t is equal to infinity after switching action, that is called t greater than 0. T greater than 10 milliseconds. After this milliseconds, okay. What is the voltage across this capacitor? Is nothing but V of infinity, that is equal to 4 plus 0. E power minus infinity means 0 and 0. Then you will get 4 volts. Okay, like this. And then we have to verify these results by using PSPAS. Coming to here, this is the circuit diagram. Okay, our voltage source is called 12 volts, and the resistance is called 4, and inductance is 1 Henry, and this is resistor 2 Henry, 2 ohms, and the switch is closed at t is equal to 10 milliseconds, and then capacitance of this switch is called 0.5 microfarad, 0.5 hours. So if you want to find the volt, our complete expression across the capacitance by taking this probe from this PSPAS. Connect here, and then we will get output. For example, right here variable label. So V out. Okay, V output. Then run this and go to analysis. Before run, go to analysis setup and transient, make tick mark on transient and select the time constant, for example, 1 second. Okay, and then go to simulate, and then we'll get this type of results. Okay, so in this result, okay, here so voltage across the capacitor initially 12 volts. So this is called 12 volts. Okay, initial conditions. And then after t is equal to 10 millisecond, greater than 10 millisecond. Okay, that means t greater than 0. After switching action, the capacitor is charged to 4 volts. V of infinity is nothing but 4 volts. No? Okay, so V of infinity is equal to 4 volts and V of 0 is equal to 12 volts. So like this, we will get the results. Okay, so by using PSPAS, we have to verify the results in this way by using in the time domain analysis. Okay, so if you want to know this voltage, select this. Okay, select this V output and then press this. Press this icon and then place mark curves. For example, take mark here and then you will get 12 volts. Okay, 12 volts. Initially, this voltage across the capacitor is called 12 volts. And then if you want to know this voltage, and press again, and then you will get like this 3.9. So here you will get 3.99, that is called 4 volts. Okay, so like this you will get the results, and then you have to verify the results by using PSPAS.